We are learning about some special functions called trigonometric ratios. The word trigonometry comes from the Greek roots trig, meaning triangle, and metry, meaning measure. So trigonometry just means the measures of triangles. What we're going to start with is trigonometry based on right triangles. But it will expand and we'll learn about how it applies to all sorts of things. But we're going to start with right triangles only. So before we fill in this chart, a little comment about right triangles. So a right triangle has a right angle or a 90-degree angle. The side that is across from that 90-degree angle, the side that doesn't touch the corner itself, but is across from it, is called the hypotenuse. Okay, hypotenuse. It's the longest side of the triangle, and like I said, it's always across from the 90-degree angle. Then you have these other two angles inside the triangle, and those two angles are going to be smaller than 90 degrees, but they add up to 90 degrees because all three angles would add up to 180. So one of them's 90, and then the other two combined with the 90 will equal 180. So let's say we're looking at this angle down here. We'll call it angle A. The side that is across from angle A, we call that the side opposite A. And then the side that's touching angle A, other than the hypotenuse, we call that the side adjacent, because adjacent means next to. If we were looking at this angle up here, angle B, this side down here is the one that's across from angle B, so we would call it opposite of B. And then this side here, that's touching angle B, we would call adjacent to B. The hypotenuse is always the hypotenuse. It doesn't change. But opposite and adjacent depends on which of the smaller angles you're looking at. Okay, so that's important to know for this next part. So sine, everybody say sine. In a right triangle, the sine of an angle is the ratio just means fraction, of the side that is opposite of its angle to the hypotenuse of the triangle. So in this case, the sine of A would be this side divided by this side, okay? Opposite divided by hypotenuse. And we abbreviate all of these trig ratios we're learning with the phrase SOHCAHTOA. And so SOH reminds us that sine is opposite over hypotenuse. So that's something that we will learn. Sine is abbreviated SIN, but you don't say sin, you say sine. Okay, the second one is called cosine. Everybody say cosine. So cosine is abbreviated COS. Oh, sorry, I have a place to write that. SINCOS. Cosine of an angle is the ratio, so again, just a fraction, of the side that is adjacent to a given angle to the hypotenuse again. So again, if we're looking at angle A, the cosine of A would be this adjacent side, whatever length that is, divided by the hypotenuse of the triangle. And in SOHCAHTOA, the CAH helps us remember that cosine is adjacent over hypotenuse. And then lastly is tangent. Everybody say tangent. And the tangent of an angle is the ratio, of the side that is opposite that angle to the side that is adjacent to that angle. And it is abbreviated TAN, tangent. So tangent is opposite divided by adjacent. So it does not use the hypotenuse at all. It just uses the opposite and the adjacent. Okay, so we're going to put this into practice. Now, before we can figure out sine, cosine, tangent for these triangles, we have to figure out the missing side of the triangle, and we have to use the Pythagorean theorem to do that. So for the first one, across from the right angle is the hypotenuse. And when we use the Pythagorean theorem, the hypotenuse has to be C. So in this case, C is 20. And then A and B are, one of them is going to be 12, and the other one is going to be what we're trying to figure out. Okay, so we'll do 12 squared plus x squared equals 20 squared, and we'll subtract 144 over to the other side, and we'll get x squared equals 256, and then square root, and we get 16. Okay, so now we're just going to state these ratios. So we're asked to find the sine of angle U. So first I have to decide where angle U is. I already know which side is the hypotenuse. The side that is across from angle U is called the opposite, so you always want to label these sides. And then the side that is touching angle U is called the adjacent. Okay? And we learned the phrase SOHCAHTOA, and the SOH tells us that sine is equal to opposite over adjacent, or sorry, opposite over hypotenuse. So opposite was 16 and hypotenuse was 20, and we could reduce that by 4, so that would make it 4 over 5. So that's a ratio, a fraction. That's the sine of angle U. Next up we have cosine. Cosine means adjacent over hypotenuse. And our adjacent was 12, and our hypotenuse was 20. And 12 over 20 will reduce to 3 over 5. And then lastly, we had tangent. Tangent is opposite over adjacent. So the opposite is still 16. The adjacent is still 12. And 16 over 12 reduces to 4 over 3. That is tangent. Okay, so next one, we have, again, we know what the hypotenuse is. We're looking at angle R, so we know which side the adjacent is. Sorry, no, opposite. My bad, opposite across from. We're looking for the adjacent. So in order to find the adjacent, since we know 2 of the sides, we're going to use the Pythagorean theorem to find the third. So we know opposite, we don't know adjacent, and we know the hypotenuse. So we've got 4 squared plus x squared equals 30 squared. We would subtract 16 over, and then we would square root both sides. Now this one is a decimal, and since it's a decimal, I can't remember if Delta Math requires that you just simplify the radical instead of using a decimal version. So I think that's what we're supposed to do. So we're going to think about the square root of 884. I know a 2 will go into that, which make it 442. So another 2 would go into that, which make it 221. And 221 is a weird number, but it's 13 times 17. So really all we can do is bring out these 2's and leave the 221. So this is going to be 2 root 221. Okay, so we know what the opposite side is. We know what the hypotenuse is, and now we know what the adjacent side is. So sine is opposite over hypotenuse, SOH, SOHCAHTOA, SOH. So sine is going to be 4 over 30, and we can reduce that to 2 over 15. Cosine means adjacent over hypotenuse, so that's 2 root 221 over 30. So that the 2 and the 30 can reduce, and that makes it 1 root 221 over 15. And then lastly, we need the tangent, and tangent is opposite over adjacent. And I'm going to do this down here. So opposite over adjacent, okay? You just took a test on this and you took a quiz on it earlier, but we can't leave a radical in the denominator. So we're going to multiply it top and bottom, root 221. So I have 4 root 221 over 2 times normal 221, because we had root 221 and we multiplied by another root 221. The 4 and the 2 can reduce, so that would make it 2 root 221 over 221. Okay, the last one, here's the right angle. We don't know what the hypotenuse is. And then if we're looking at angle G, we've got the opposite side and we've got the adjacent side. So tangent would be opposite over adjacent. And if we look up root 97 on the chart, it's prime. So I can't simplify it any. So I just got to multiply top and bottom. So the bottom becomes a normal 97. And 47 is also prime. So it's just a prime number times a prime number. So 47 times 97 is 4559. And I know this isn't a pretty number, but it is still a number. You know, don't discriminate against ugly numbers. We care about them. Okay, so tangent would be opposite over adjacent. That's root 47 over root 97. That's what tangent is, but we can't leave the root 97 in the denominator. So we multiply it top and bottom. And on the bottom, root 97 times root 97 is a normal 97. And on the top, root 47 times root 97 is root 4559. And that root can't simplify because this is a prime number and this is a prime number. There's no other numbers to break it down into. Okay, so let's go back up to sine and cosine. So in order to find sine or cosine, we have to know what the hypotenuse is. So we have to figure that out, and we're going to use the Pythagorean theorem to do so. So a squared plus b squared equals c squared. C is the hypotenuse, so that's what we don't know. And then a would be root 47, and b would be root 97. And if you square that root, it's just 47. And if you square root 97, it's just 97. When you add those together, you get 144. Now that's a nice number. Look at me, I'm discriminating now. Sorry, not 21, 12. My dyslexia kicked in. Okay, so the hypotenuse is 12. So since sine means opposite over hypotenuse, that's going to be root 47 over 12. And since cosine means adjacent over hypotenuse, that's going to be root 97 over 12. Those are our final answers there.